So today we're going to discuss rational exponents. This is in your most recent yellow packet of your notes. I'd like you to first try the warm-up. It's a review of the multiplying binomials and then also some exponent rules. So please try the warm-ups, and then as you can see the answers there, you can check them, but please make sure that you can do them on your own. Now, once you are done with that, what I'd like you to do is, each time I move this slide over to the next one, I'd like you to pause the video and write down everything that's on the screen, and then start listening again to, once you're done, to what I have to say about the notes. But it would be best if you'd write everything down, and then I'll go through and explain it to you. So please make sure you are pausing the video as needed as you're taking your notes today. So, like it said, as we had worked before, we looked at x to the cubed. We know x to the negative 3 becomes 1 over x cubed. That negative moves it down to the basement or the denominator. And then x to the 0, anything to the 0 power is 1. Now, when I do come back, I'll show you in your quiz. Some of you made it x to the 1, and you left the x there. But remember, that whole thing does become 1. So now, today what we're going to look at is fractions. What happens if our exponent is a fraction? And that is part of the reason you had done those bell ringers dealing with fractions, because we're going to use those properties today and those rules with fractions. So, well, as we know, with the radical, that number is what we would divide by. So that number in the denominator, that 4, is actually our index number. So it is great if you can learn that terminology, index versus exponent, and things like that. It'll make things easier. So 4 is the index. That's the number outside of the radical sign. And then that 3 was in the numerator, so that is your exponent. And so in this case, we would get the 4th root of x cubed. So part of the homework and part of the work notes here is just going to be, can we write it from one form to the next? And so that's what we're going to be looking at. So again, when I show the next slide, please pause it, write it down, and then listen to the video when you are done. There's not much to write on this one. Again, just make sure that you are looking at everything. So again, that n, that index number, is always now going to be on our denominator. So remember, if it's a square root, there's no number there, but it is 2. Some of you are like writing the 2 in, which will make this section a little bit easier. If you haven't, that's fine. But anything to the half power there is going to be like a square root. And again, if there's a exponent in there, that just goes on top of the n. Now notice, in that last section there, the m can either be inside the radical sign or it can be outside. And so when we do some problems today, it's going to be easier to take the radical, break down a small number, and then cube it or square it or whatever we need to do for the exponent. So either way you write it is going to be helpful. Again, n can't be 0, and then, or excuse me, it says a there, but it should be n. Can't be 0. We can't use 1 or 0 for the index there. Has to start at 2. All right, so the next slide here is just rewriting it from one form to the other. Okay, first one, not too bad. X to the 3/7. Well, that 7 is in the denominator, so that's our index, and then 3 is our exponent. So it's x to the 3rd, the 7th root of that. Now, the next one's a little bit more tricky because you see it's not a fraction, it's a decimal, so we have to write it as a fraction. Well, 3.5, hopefully you understand that that 5 is in the 10th place. So if I multiply everything by 10 there, divide it really, I'm going to get 35 over 10 because that 5 is in the 10th spot. It is negative, so as we know, that negative moves it to the basement. And then I don't like large numbers, so I'm going to reduce the 3510. So when I do that, I can take a 5 out of each. So 5 goes into 35 7 times. 10 goes in, or sorry, excuse me, 5 goes into 10 2 times. So I get negative 7 halves. And then remember that 2 is like the square root. So I get 1 over the square root of y to the 7th. So again, just to kind of recap, if you're given a decimal, you need to write it as a fraction. Since the 5 is in the 10th spot, that's where I'm going to use my denominator of 10. If it was 0.05, I would make it 35 over 100. Okay, or 305 over 100, because it was in the 100th spot. But that 5 is in the 10th. I like to reduce it. I'd like you to also reduce it. So we get negative 7 halves Remember, the negative moves it to the basement, and then we change it into the form. Now, what happens if I give you the radical form and say, hey, I want you to write the exponential form? Well, again, in that first example, that number outside the radical, it's not a 1, it's a 2. Because remember, we circle it in groups of 2. So we're going to get a to the 5/2. 5 goes on top, that 2 on the index is our denominator. Next one, we have b to the 3/5. The difference here is that 3 is on the outside of the parentheses. It doesn't matter. It's still an exponent. It still has to be on the top. So now I'd like you to try the next ones and kind of see how it goes. So I'm really hoping that you tried these on your own. I know it's much easier just to copy what I wrote, but it's not going to help you. So again, hopefully you are trying these U-tries on your own. See how it goes. It'll make the homework easier later. So we want to rewrite in radical form, so that means we need that radical symbol. Again, that negative brings it down to the basement. 8 is in the denominator, so that's why it's the 8th root of w to the 5th. Next one, again, notice it is that decimal, so it's 2 over 10, because 2 is in the 10th spot, but that reduces to 1 over 5. So then we get the 5th root of w. If you put the 1 in next to the w, awesome. If you didn't, you don't need it. Either way is fine. Writing into exponential form, notice it is x to the 3 divided by 4. 3 stays the exponent. 4 then is in the denominator of that exponent. Next one is y to the 4 over 5. So again, just going from one form to the other. Next page again, just reviewing all those exponent rules that we have. All of those exponent rules apply even if we have a fraction. Okay, so anything that we've done in the past, it's nothing new. It's just, of course, we have fractions, and that's why we need to practice our fraction rules so we know what to do when we see them. So let's try a couple problems here. All right, so when we look at this one, we need to simplify these. Well, it looks very difficult, but if we change things into radicals, it's a lot easier. We can make our factor trees and we're set. Okay, so we have to think, how do I write 1/3 as a radical? Remember, the 1 just means there's one of them, and the 3 means it's a cube root. So as you notice, I changed that 216 to the cube root, and then I just made my factor tree. I have a group of 3 3s and a group of 3 2s. Multiply that together, I get 6. Next one, I'm going to change this also. The square root of 7 times the square root of 7 is the square root of 49. Well, if I make my factor tree, or as you guys know, you're going to get 7. Now you notice I did put an or here. Well, our rule with fractions, if the base is the same, I can just add those exponents. Well, a half plus a half is 1. So if you know your fractions, how to add those, that might be easier. Now, next one, the bases are not the same, so we can't do what I did in B for that one. This one, I actually wrote them as radicals. Then I could multiply them. I decided to keep them separate, but remember, when you multiply, you can share those 5s. There's 4 5s. I circled those. I get my answer is 5. Okay, so again, look through what we did. It's very similar to what you have done the last few days with those factor trees. Okay, but make sure you can convert it from the radical to the, exponent to the radical. So again, square root is the half, 1/3 is the cube root, anything like that. Next one, again, is for you to try on your own, so please try those. Pause the video, try them on your own, see how you do, and then look at my answers. 4th root of 64, you break that down, you get 4 2s, but notice how I had a pair of 2s that were not used. So I have to multiply those, and I get that 4th root of 4. Next one, again, I can't multiply the 3 and the 12, or add the halves, because it's 3 times 12. If it was 3 to the half, you could, but the bases are different. So I change them to the square root of 3, square root of 12. Break down 12, I get 4 and 3. I have those pairs of 3s I can combine, and the 2, that gives me 6. Or multiply it, the square root of 36 is 6. Next page. Okay, same idea, just different numbers here as we write it, but we don't have a 1 in our numerator anymore. We have something else. Again, with the decimals, we have to change them to fractions. That 5 is in the 10th, so I get 25 over 10. That becomes 5 over 2. So now I have 16 to the negative 5 halves. Negative brings it to the basement. It does not make a negative. The 2 makes it a square root, and the 5 means I have to go to the 5th power. Well, I don't want to take 16 to the 5th power and then try to break that down. So it's much easier and quicker if you do the square root first and then do that to the 5th power. So the square root of 16 is 4. 4 to the 5th power is 1024. Remember, it is in the denominator, so it's 1 over 1024. Next one, negative 32. I want to take the 5th root of that because 5 is in the denominator, and I want to take it to the 4th power. So I break down 32. Yes, I can break it down. 5 is odd, so you do get an answer. Get negative 2. Negative 2 to the 4th power. Well, negative 2 times negative 2 is a positive 4. You do that again, you get another positive 4, so you get 16. Now again, you have calculators, so you could type in negative 2 to the 4th power in your calculator and get the answer. I will need to see you do the factor tree, though. You cannot just type in negative 32 to the 4/5 in your calculator. And we'll talk about that more when I get back, hopefully on Friday. Again, hopefully you paused the video and tried these 3 on your own, or pause it now and try it without looking at the answers until you are done. Notice on A and C, they're both negative, so you should have fractions there because all of your answers would have been in the denominator. 5th root of 32 is 2. If I cube that, I get 8, so 1/8 for A. 4th root of 16, we actually did that earlier, I believe. And you get 2. Again, I'm going to cube it after I take the radical. It's just numbers are smaller, much easier to do. 2 cubed, again, is 8. Next one, that fraction becomes 35 over 10, which we've looked at. That becomes 7 over 2. Again, it's negative, so I have to take the square root of 9 and then move that to the 7th power all over 1. Now, again, I did say if an exponent is higher than 5, you do not have to put it in your calculator. So if you had 1 over 3/7, that is going to be fine. I did type it in the calculator and got 2,187. So you can have either answer there for that. Again, if you have questions on this, please pause it, move it back to the page, try to watch it again and see if that helps. And again, help each other in class. If someone definitely understands it, have them explain it to you. But again, make sure that you are somewhat quiet so that the others can continue working. Now we'll look at the next information. So notice here we're going to be looking at letters also. So the first one, again, 1/5 is the same as the 5th root. Everything to the 1st power, and then I want to take the radical. So if I do that with negative 243, I break it apart, I get 5 3s. Notice my answer is negative. That is because the 243 was negative. Now, I did put the y to the 20th under the radical. Would you have to? No, because you could distribute that, and you know 20 divided by 5 is 4. But again, I think a lot of you find it easier if it's under the radical, so that's going to be your choice. And then again, 20 divided by 5, there you'll see is 4. So your answer is negative 3y to the 4th. Next one. I would distribute the half to everything. Okay, so I have 2 ways that I did this. One is you make the square root of everything, or I like what I did on the right side. I think it makes more sense to what you've done in the past. Distribute the half to everything. This again is where knowing what to do with fractions makes it so important. So there's an exponent of 1 by the 4. So 4 to the half power. Now, a half times a half becomes 1/4. Remember, when you multiply straight across. So 1 times 1 is 1, 2 times 2 is 4, so you get a 4th. The next one, 3/10 times a half. Well, 3 times 1 is 3, 2 times 10 is 20, so you get 3/20. Well, 4 to the half power, remember half just means square root, so the square root of 4 is 2. Y to the 1/4, well, I have a y to the 3/20, so I need to combine them, so they need common denominators. So I need the common denominator of 20. Again, when you add, you need common denominators. So the 3/20ths is fine, but I need to change that 4 to a 20, so I have to multiply everything by 5. So I get 5 over 20. So 5 plus 3 gives me 8. I get 8 over 20. Now again, you can see that I don't have that in my final answer. I personally like to, again, simplify those fractions. So 4 goes into both, so that's where the 2/5 comes from. Okay. Again, a lot going on. Pause the video, rewind it, listen to it again if you need to. But when multiplying fractions, you add them. When multiplying fractions, you multiply across. When adding them, you need to get common denominators and then add them together. So you'll be doing a lot of that in this section. So again, if needed, go back to those bell ringers that you did with the fractions and see how those went. Please try the next ones on your own. See how far you can get, and then look at my answer key and see if you can figure out how to fix if you got anything incorrect. Alright, so the first one, again, I changed to a radical. So I made it a negative by converting it into a fraction. The 1/3 is the same thing as the cube root. Well, the cube root of 8, I did not write the factor tree, but 2 times 2 times 2 is going to be 8. So I'm going to have a 2 out there. And you can either draw out the 15 x's and circle them, or take 15 divided by 3 and you get 5. So you get x to the 5th. Notice on B, that exponent is also negative. So again, it has to go to the basement. Well, I'm going to take the 4th root of 16y to the negative 8, but then I have to cube it. Okay, so again, I like to break it down and then cube it. And that's what I did right below in those parentheses. So again, the 4th root of 16 is 2. That means just break down the 16, make your factor tree. And then y to the negative 8, well, negative 8 divided by 4 is 2, but it's negative, so it has to go to the top. So that's why I have y squared over 2. Well, again, don't forget, you still need to cube it. There's that 3 there. So I get y to the 6th. Remember, you multiply 2 times 3. That's those rules of exponents. And then 2 to the 3rd. Well, 2 times 2 times 2 is 8. Again, if you don't like that, using the radical, you can distribute the 3/4 all the way. So that's what I did. 16 to the 3/4 and y to the 24 over 4. That 24 over 4, well, that's y to the 6th. And then I broke down. I didn't show it because it's on the right side. But I took the 4th root of 16 cubed, and that gave me 8. All right. We are getting there. We just have a few more slides left. Again, another image of all those exponents, because it's that important that you know all your exponent rules, and with your fractions. Okay, so see how this goes? This will definitely review more, but I think this is important. If you saw this question on the last quiz, you would have said, hey, I can't simplify it, the indexes are different. However, we now know how to write those as fractions. And fractions and exponents, we know we can use our exponent rules. So we write it as a radical, 3/4 on top, x to the 2/8 on the bottom. Well, if I reduce the 2/8, I get 1/4. So I have x to the 3/4 on top, x to the 1/4 on the bottom. Well, now, who remembers what to do with our exponents if we're dividing? Remember, we subtract. Well, in order to subtract, they have to be the same denominator. Ah, they do. It looks great. So 3/4 minus 1/4 is 2/4. Well, I can reduce that, so I get x to the half. Well, because this problem was given as a radical, I want our answer to be as a radical. Okay, if it's given as an exponent, feel free to leave it as an exponent. But these were radicals, so we have to rewrite them that way. So x to the half, remember that 2 is the index. I didn't write it, but we know that that's the square root, and there's just 1x, so the square root of x. Again, the second example here, you would say, hey, I can't solve it, indexes are different. Well, now you can. So when you see this on your next quiz and your next test, I do expect that you do solve these. So square root of 3 is the same as 3 to the half. Then you have 3 to the 1/4 for the 4th root of 3. Now, this time they do not have the same denominator, so we have to get that. The half becomes 2 over 4. Multiply top and bottom by 2 over 2. Now your denominator or bottom is 4. Now you can add them. So 2 plus 1 is 3, so you get 3/4. Now again, write it as a radical. 4th root of 3 cubed. Well, 3 cubed would expect that you would know, or you could plug in your calculator and get 27. So the 4th root of 27 is my preferred answer. Biggest thing with these is knowing when you need to get those common denominators. Because we're adding and subtracting with multiplying and dividing, you will need to get common denominators here. Okay, so change everything to fractions, then you can solve all these. Okay, we can do this one again together, and then I'll have you try the next one. So again, notice on that top, on this one I have the square root of 3. Well, remember that's a 2. And so it's not 3 over 1, it's 3 over 2. So we have x to the 3/2. Now on the bottom, we're going to have x to the 2/3. So with that, I need a common denominator of 6. 2 and 3, the only number they have is 6. So on the top, I get 9/6. The bottom, I get 4/6. Again, we're dividing, so we're going to subtract. 9 minus 4 is 5. Denominator doesn't change. That's a 6. So then we get the 6th root of x to the 5th. 5 goes with the x. It's your exponent. 6 is your index. Next one. Again, we're multiplying. A square root is to the half. So 7 to the half, 7 to the 3rd. Common denominators. Just like the last problem, you need a common denominator of 6. So we are going to get 7 to the 3/6 and 7 to the 2/6. Multiplying the first fraction by 3 over 3. The second fraction by 2 over 2. Now denominators are the same. We can add them together, so we're going to get 5/6. So we get the 6th root of 7 to the 5th. Pause. Again, with those videos, it's awesome because you can pause them, you can re-listen to it, and see if you can make more sense if you are still having questions. This section is just combining kind of everything we've already done with exponents, but using fractions instead of whole numbers. So you do need to know those rules with fractions. All right, next ones are kind of tricky, but I think you can do it. See what you can do. See what you can come up with. The last page here. So hopefully you tried a couple. These are tricky. They really make you think about your decimal order, PEMDAS, and things like that. So let me talk through it. If you couldn't get A, just try A with me, then pause the video, try B on your own, see if you can get that one to work, and then see where you're at. So for the first one, you want to distribute the 2/3 to everything. So you notice the -8 is to the 2/3. Probably should have put parentheses around the -8. In the end, it doesn't matter because it's cubed, but better practice is if I'd have a negative, parenthesis around the -8. X also goes to the 2/3. Well, now what in the world do we do with that square root of xy? Well, you notice above that, I wrote that with halves. So x to the half, y to the half, because that's as it is as a exponent. Well, now if you take a half times 2/3, the 2's cancel. Or you would get 2 over 6, which reduces to 1/3. So x and y are both to the 1/3 power. Well, now I get to simplify everything. Numbers, I always change it to a radical. Okay, so you take the cube root of -8 and you square that. And then you use your factor tree. You're going to get -2, but you square that. -2 times -2 is a +4. Now x's I can combine together. Now I did change them to 6's. You wouldn't have to do that. You could leave it 2/3 and 1/3 and you just get 1. You didn't have to change the denominators because they were both 3. And then y to the 1/3 you would leave. Now, you could have changed the y to the cube root of y, and that would have been fine. I left it because the original answer, most of it was already exponents at 2/3. But either way would be fine. Next one. Again, distribute the 3/2 to everything. So you get the square root of 9, which I have cubed. So square root of 9 is 3. 3 cubed is 27. Now the letters. X becomes x to the 3/2. Notice I changed the y to the 1/4, and then I distributed the 3/2. Well, 1 times 3 is 3, 4 times 2 is 8, so I'm going to get 8 there. So I'm going to get x to the 3/2, y to the 3/8. If you left it as 27x to the 3/2, y to the 3/8, that's perfect. Or, as you can see, I squared it. This time I changed it to a radical because there was a radical in the problem. Either way is going to be fine. Generally, I would say if there's exponents, leave it as an exponent. If it's a radical, change it. A lot of times I'll tell you too on the test what form I would like it in. X to the 3/2 becomes the square root of x cubed. Notice for y, there's an 8 in the denominator, so it's the 8th root of y cubed. I hope to be back tomorrow. So then we can go through this some more. Next, once you are done with the notes, you have them filled out, you've gone back and tried some on your own, and just kind of listen to some of the explanation again when needed, then you can get the homework assignment. It's a 6.4 worksheet. The sub has the answers in the subfolder, so feel free to hang them up, or if they're already hung up, period 5, 6, that's fine, or have them, she can leave them on the desk and you can look at them there. But you can look at some of those examples. And if you guys finish with all of that early with time left, I will have another Google Classroom assignment that she may assign. If the sub doesn't assign it, we'll look at that when I get back. Hopefully, like I said, on Friday. So, good luck with this. Again, it's a lot of review, just putting it all together. Tough with the fractions, but I know you guys are smart and can do it. Please help each other out. You guys usually work well together. So, good luck with this. Have a great day.